All right, today we are going deep, and I mean literally deep underground, to talk about a brand new technology that can send signals where they have never, ever been able to go before, straight through solid Earth. So how on earth is that even possible? Let's dig in. First up, let's start with a problem we have all had. You're on a call, you drive into a tunnel, or maybe head down into the subway, and boom, silence. That super frustrating dead zone is the exact problem we're talking about today. But what is actually happening when your signal just vanishes like that? See, to really get why this new breakthrough is so cool, we first have to understand the problem. And it turns out, the air all around us and the solid ground right beneath our feet, they are two completely different worlds for wireless signals. Above ground, we are just swimming in a sea of connectivity, right? You've got your cellular, your Wi-Fi, GPS, you name it, we've got it. But the second you go underground, it's a totally different story. It becomes a digital desert. And that is the fundamental challenge that scientists have been trying to crack for years. The scientific villain in our story here has a name. It's called attenuation. A good way to think of it is like trying to shout through a really thick wall. Your voice, which is the signal, just gets absorbed and muffled. Well, in this case, the wall is tons of soil and rock, and our normal radio waves just can't punch through. To beat attenuation, you need a completely different kind of signal. And that, right there, brings us to the breakthrough. Researchers at South Korea's Electronics and Telecommunications Research Institute, or ETRI for short, have figured out a way to get around that massive wall of rock and soil. And they did it over a really impressive distance, 100 meters. Now, that's about the length of a football field. In a world of global satellites, I know 100 meters might not sound like much. But trust me, when you're sending a signal through solid ground, it is a massively forward. So what's the secret sauce? How did they do it? Well, instead of using those traditional radio frequencies that just get blocked, the ETRI team used magnetic fields. And that is the core of this whole innovation. It's a completely new way of thinking about how to send a signal through the Earth. And listen, this wasn't some overnight success. Just a few years back, the team managed a 40-meter transmission, which was already pretty cool. But now, by refining their whole magnetic field system, they've more than doubled that distance. It just proves that this technology is getting more powerful and way more practical, fast. So, how does this magnetic magic actually work? Well, the real key is in how this new method stacks up against the old one. Okay, here's the main difference. High-frequency radio waves are kind of like tiny, fast-moving bullets. They just slam into dense materials and get blocked or scattered everywhere. But low-frequency magnetic fields, they act totally differently. They can actually propagate or sort of seep through solid ground with way less of that signal-killing attenuation we talked about. And the setup they used? It's actually surprisingly straightforward. It uses a 1-meter loop antenna to generate the magnetic field, and then a really small sensor to pick it up on the other side. Get this, they even tested it in limestone bedrock, which is a notoriously tough environment for any kind of signal. And it worked. That proves this whole approach is tough enough for some serious real-world challenges. Okay, the science is definitely impressive. But what's the real-world impact here? I mean, why does communicating through 100 meters of solid rock actually matter? Well, as it turns out, it could literally be a matter of life and death. The potential uses for this are just incredibly broad and so important. Just imagine being able to talk to miners who are trapped after a collapse, or first responders trying to navigate a subway tunnel during an emergency. This could also be a game changer for national defense or for communicating with equipment deep down on the ocean floor. This is where the technology could truly save lives. So, is this the future? Are we about to get magnetic cell service in our basements? Well, let's not get ahead of ourselves. There are still a few challenges to work through before that happens. The main one right now is speed. The data rate is only 2 kilobits per second. Now, to put that into perspective for you, we are talking about internet speeds from the early 1990s. It's slow. But think about it for a second. You don't need to stream Netflix when you're trapped in a mine, right? At 2 kilobits per second, there is more than enough bandwidth for voice calls and simple text data, the exact kind of communication that saves lives. So yeah, the speed is a limitation, but it's also perfectly suited for the job it was designed to do.
And that really just sums it all up, doesn't it? This isn't about replacing the networks we use every single day. No, this is about building entirely new networks for the places our current technology just can't touch. It's about finally filling in the last remaining dead zones on and under our planet.
Which leaves us with this really fascinating question for the future. As we keep pushing the boundaries of what's possible, could it be that the next great leap in wireless technology won't be in the airwaves above us, but in the magnetic fields running deep within the Earth itself? Something to think about.